Hello, and thank you for welcoming me to my first ever paleoanthropology talk, which will, I'm sorry to say, largely focus on modern human biology as prelude to the next talk by my friend, colleague, and co-author, Dr. Sarah Lacy, who I promise will be more paleoanthropologically focused. Adrienne Zillman got it exactly right when she said in Woman the Hunter, popular pictures drawn of the past are too often little more than backward projections of cultural sex stereotypes onto humans who lived more than 1,000,000 years ago. To the right here is Kathrine Schweitzer being pulled off the 1967 Boston Marathon course in a manner not dissimilar from depictions of cavemen dragging cave women along the ground. And it begs the question, which inspired which? What you see here playing out is the idea that females are not suited for rigorous physical activity, both then and now, and should assume a more submissive, calm role. This thinking has shaped our reconstructions of the potential past repertoire of activities females took part in, such as hunting. And roughly a year after Schweitzer finished that marathon, these ideas were formalized anthropologically in the 1968 edited volume, Man the Hunter, based on a 1966 symposium of the same name. Even though this work is over 50 years old, the idea of a deep sexual division of labor that paints males as dominant and prominent persists. Males are depicted as the hunters, providers, and evolution acting upon them is the reason for our uniquely human features, whereas females were relegated to mere beneficiaries of evolution acting upon males, and the female role was one of only mothering and gathering. And though things have gotten better academically and athletically, as can be seen here by Schweitzer reprising her run of the Boston Marathon in 2018, and just a sampling of the foundational feminist anthropological work that has been done, there is still a long way to go, as we saw in the recent Summer Olympics in Tokyo, where two Namibian runners, Christine Mboma and Beatrice Msilingi, were barred from the Olympics for naturally high testosterone levels, or in other words, they didn't fit the mold for what females should be and look like. We also still see deeply sexist analyses and peer review work to this day. My goal here with this talk is to walk you through some of the physiological evidence that suggests females are just, if not more capable than males of performing arduous physical tasks, and that this evidence, along with greater research among females, needs to be taken into account when reconstructing the past. However, before going into that physiological evidence and some anatomical evidence, I'd like to just make a brief note about terms on sex and gender. I recognize fully that gender exists on a spectrum and sex exists on a spectrum, and this is laid out wonderfully by the infographic in the New York Times. Many people would like to think that sex exists on a binary, but the more we learn about sex and gender, the more we realize that it is truly a spectrum. However, much of the work that I am building this talk around is the exercise physiology literature, and it typically uses female and male as a binary when collecting data and analyzing data, and they typically define this as sex assigned at birth. As such, to match what this research says and to not misrepresent it, I will be using the terms female and male. I would also like to say that I will not be addressing transgender athletes in this talk at all. However, a great deal of work needs to be done among transgender athletes, especially in light of the horrifically exclusionary policies that are being put in place quite often and regularly right now in the United States. So I want to put that call out there and also recognize that sex and gender exist on a spectrum, but I am constrained a bit by the terminology that I need to use here in this talk. I would also like to recognize that exercise physiology research is biased. From 2011 to 2013, females made up only 39% of participants in exercise medicine studies. And while that improved slightly to 42% in 2015, it didn't improve to 42% across the board. As you can see with research that looks at only exercise performance, women only make up 3% of participants. And unless individual or researchers are looking at the social aspects of exercise, or if they are looking at diseases associated with exercise, females are always overwhelmingly underrepresented in exercise physiology research. And this is also true in terms of the researchers themselves. Females make up very few of the researchers within exercise physiology. And then finally, this talk is not here to say that there are not real and uncontroversial differences between females and males. They are, and we know them. We know that on average, males are larger, they have more upper body mass, larger hearts, and larger lungs. But there are also advantages conferred to females, but those are the ones that are often ignored and far less well known among the general public, as well as even among researchers. And so my hope here is to give those features a bit more attention. And the hope in giving that more attention is that better understanding female physiological capacities could help reshape our reconstruction of the past to come up with a more accurate and better representation of the past. And so let's start with anatomy. We are all aware of the well-known sexual dimorphism in pelvis shape, with females having relatively wider pelvises than males, which has often been assumed to burden females with inefficient, more costly locomotion. However, recent work by Wall, Scheffler, and Myers suggests that the greater mediolateral breadth confers a locomotor advantage to females, especially when carrying a load, such as a child. Despite the load being used in these studies, which was an 11-kilogram child mannequin, which, by the way, was a proportionally greater load for females based on body weight, females had absolutely lower cost than males and adopted faster self-selected minimum walking speeds. They also adopted greater stride lengths relative to males, suggesting that females were better at adapting their locomotion to the hip-placed load of a child. Another part of anatomy that is different between males and females is the number or the type of muscle fibers that they have. Females are more abundant with type 1 muscle fibers, and these muscle fibers are the slow oxidative, the endurance muscle fibers, the ones that can burn for a very long time at a low level, but a submaximal level. So your marathon muscle fibers, whereas males tend to have more type 2X fibers, which are the fast glycolytic fibers, associated with power movements, really quick, very strong movements. And so females, when it comes to fiber type distribution, seem to have an advantage aerobically for endurance exercise. Physiologically, I would like to focus mostly on estrogen, because estrogen is not just for reproduction. And much like testosterone, estrogen is present and needed both in females and males. However, most of us are familiar with the reproductive effects of estrogen. But there are also some really interesting impacts that estrogen can have on athletic performance and physical performance. And those are the ones that I would like to cover today. So the key form of estrogen involved that is important in parts of physical activity is 17-beta estradiol, which is going to be abbreviated as E2 in this talk. And it's typically higher in females. Estradiol can shift fatty acids towards the heart and skeletal muscle, and this is particularly important during exercise, as utilizing fatty acids helps individuals take part in endurance activity for a longer period of time. Fatty acid oxidation is also critical for protein sparing, so not burning through your own muscle mass. And the fatty acid oxidation is also very important, or at least so we think, for fatigue resistance. So the greater fatty acid oxidation one has going on during physical activity, the longer until they actually burn out from that physical activity. Estradiol also helps improve skeletal muscle insulin sensitivity. And so this is important for utilizing glucose within the skeletal muscle during activity, but it also might be quite important when it comes to risk of diabetes. Males are much more likely to have diabetes than females are, and it could be because of estrogen and the effects that estrogen has on being able to help sequester insulin in places such as skeletal muscle. Females also tend to have a greater abundance of estradiol receptors on the skeletal muscle. And again, that's going to help with the fatty acid oxidation, as well as insulin sensitivity and glucose utilization. Interestingly, endurance trained males also have a higher number of estrogen receptors on their skeletal muscle mass. However, at this time, we're not sure if this is something they are born with, so the nature aspect and they self-selected becoming really good endurance runners, or if this is something that can be trained and increased over time. So more work needs to be done in that area as well. Estradiol is also related to greater lipid content within skeletal muscle. And again, that higher lipid or fatty acid content can help muscles go longer during endurance activity, spare muscle from being burned, and again, reduce fatigue. As we are learning, females seem to have much greater fatigue resistance than males do. And so hopefully I've expanded your view on the different things that estrogen can do and how they are related to physical activity. So they can increase muscle recovery and repair, can also increase growth hormone production. A few of these are things I haven't really gone through. It increases the number of androgen receptors overall, increases fatty acid oxidation, glucose disposal, and insulin sensitivity, and can even increase serotonin levels, which can allow an individual to train harder, which also makes it increasingly interesting that sporting bodies are not regulating natural estrogen levels the way they regulate natural testosterone levels. So another inequity that we see, not just in how females are researched, but how they are treated by sporting bodies. Another part of the physiological evidence that's been ignored is adiponectin, and this is a hormone that regulates glucose as well as fatty acid oxidation. And females have as much as 65% higher levels of adiponectin than males, and this again can help with fatigue resistance. Females also experience reduced muscle damage during intense exercise. And this comes from studies looking at heat shock protein response post-exercise. And females have a lower heat shock protein response relative to males. This is the body's response to an elevation in body temperature during exercise. And heat shock proteins can actually lead to tissue damage. So females experience less tissue damage than males. And this might be related to estradiol, but still a whole lot of work needs to be done. And it's adding to a growing body of evidence that females are durable and males are sensitive, that females are able to physiologically manage any perturbations to homeostasis or perturbations to the environment far better than males. And we see this with some of the exercise physiology literature, as well as work coming out by myself, Peter Gray, Elizabeth Joe, and Waxenbaum as well. There's this idea that of a durable female, sensitive male, hypothesis that really does need to be tested more into the future. And then females seem to be better at psychologically pacing themselves during marathons. In particular, females slow less than males throughout marathons. They're able to maintain a more consistent pace throughout, whereas males tend to slow down more towards the end. And so this is kind of a summary slide of all of those different things that show that females are seemingly better suited for endurance activity than males. And then a study by Bam et al. From 1997 showed that females would likely be outpacing males at any sort of endurance at 65 kilometers or greater. We'll see them outpacing males. And so it really does kind of beg the question of, why might there be this improved endurance performance among females relative to males? And I think it might be related to the dual demand on females to be highly physically active while also caring for children and gestating children, that these dual demands were likely a strong evolutionary pressure shaping these endurance capabilities among females. And I think this is a wonderful example of that with a picture of a scene from Clan of the Cave Bear with Ayla both carrying a massive amount of things on her back as a child. And then this really powerful picture of Sophie Power breastfeeding her son Cormac during a 106-mile Ultra Trail du Mont Blanc race marathon. Instead of resting in between legs of the race, as you see the man here basically passed out next to her, she's having to breastfeed her child, thereby not only expending a huge number of calories to the ultra marathon itself, but also to the process of breastfeeding. And so it is patently absurd in my mind on physiological, cultural, and archaeological grounds to think that females weren't capable of taking part in any and all of these same activities as males. Culturally, we see that with work among the Agta, where female Agta individuals hunt, even while they're pregnant, even days after they have given birth, and with more reconstructions of the past, as we've seen with a recent paper of reconstruction of an Andean female hunter that you see here on the right. However, in order to better recreate more realistic and accurate representations of past female behavioral repertoire, we need to better understand the female physical activity and physical capability repertoire today, because how can we hope to understand our past if we ignore half of our present? And with that, I would like to thank you for your attention and then turn it over to my friend and colleague, Dr. Sarah Lacy. Thank you.